Steam generators are essential for transferring energy from the nuclear reactor to the turbine. As the tube bundles age, less heat is exchanged between the primary and secondary systems. When a large number of tubes have failed, the steam generator is replaced. This is a strategic operation that contributes to plant life extension. To carry out this operation, 4 companies have formed a consortium to combine their experience in steam generator replacement. Around 40 contractors are working with them. There is only one interface between the customer and the consortium, thereby ensuring efficient operations management and transparency between the various stakeholders. Eiffel is responsible for the steelwork. Oris is in charge of logistics, interferences, and heavy handling operations. Käfer-Werner is responsible for heat insulation, scaffolding, and biological shielding. Areva NP, as consortium leader, carries out the steam generator replacement operations and coordinates the consortium members. Steam generator replacement is the largest operation covered by a single maintenance contract in France. The on-site operations alone represent around 200,000 working hours, with a further 100,000 hours at least for design and engineering. Our companies worked together as a consortium twice in 2007 for EDF at Bouget 4 and Chinon 1. The co-responsibility rules were set up and presented at the kickoff meeting, along with the organizational structure, the integrated teams, and the performance and safety objectives. Let's run quickly through the main stages. Preparing the logistics. Installing biological shielding. Removing heat insulation. Cutting up secondary pipes. Removing superstructures. Cutting up the steam generator. Removing the upper part. Cutting up the primary coolant pipes and removing the lower part. Decontaminating and preparing pipe end pieces. Preparing equipment outside the reactor building. Installing new upper and lower parts. Putting the superstructures back in place. Performing the final weld to assemble the lower and upper parts. Connecting the steam generators to the primary coolant and secondary pipes. Replacing heat insulation. And lastly, restoring the reactor building configuration. Now let's look at the operation in detail. Bouget 4 is something of a special case since the new steam generators are delivered in 2 parts. The outside is protected with removable coating and the inside is in a nitrogen environment. The reactor building is prepared. All the equipment is cleared from the operating floor and the missile slab is taken out of the reactor building. In all, more than 800 containers have to be handled during the operation. The tools are prepared outside the reactor building to optimize operation organization and safety. The special access platforms are erected. The steam generator cubicles are confined with plastic covering to prevent insulating material from being spilled inside the reactor building. Then we can remove the heat insulation from the old steam generators, sort the waste so that it can be stored according to category, and install 100 tons of biological shielding on the components and pipes to protect personnel. Scaffolding is needed to dismantle the existing floors. The heavy floor and the sliding beams are adjusted. Once the personnel airlock has been removed, they will be at the center of each component handling operation. Temporary decking is placed over the cavity to support the jib crane and also provides extra storage space. The cable tensioner and its lifting beam are hoisted onto the polar crane girder, ready to lift the steam generators. The jib crane moves into position on the cavity deck. Along with the polar crane, the teams now have 2 handling devices in the reactor building. The work area is ready for the secondary circuit to be cut up. The pipes on the feedwater line are machine cut and finished off with a cutting wheel to make sure the inside of the equipment remains non-contaminated. Then the steam line is disassembled. The superstructures surrounding the steam generators are removed, leaving ample space for safe handling. This is only a very small part of the 120 tons of steelwork that will be picked up and set down during the operation. The removable walls around the steam generators are unbolted. A diamond wire saw is used to cut an opening in the concrete wall between the steam generator and the pressurizer. The upper part of the steam generator is cut. A flame cutting process has reduced the time required for this operation. The upper part is hoisted, blanked off, and taken to the temporary storage building. Now the reactor coolant pipes are all that connect the lower part of the steam generator to the rest of the system. They are separated using an orbital cutting machine. The lower part is freed along with its biological shielding and its conical lifting collar. Blind flanges prevent contamination from leaking out. The overall handling operation lasts 6 hours. The lower parts of the 3 steam generators are also taken to the temporary storage building. The steam generator connection loops are decontaminated simultaneously on the hot and cold legs. Photogrammetry is used to obtain fit up to within 1/10 of a millimeter. This degree of precision guarantees optimum machining of the primary loops, which is an essential operation for connecting the new steam generators. Once their protective coating has been removed, the steam generators are prepared and fitted out. The welding coupons are carried out in line with the qualified welding procedures. The next step is to move the steam generators into the reactor building. The most delicate step is to fit the lower parts of the steam generators onto the connecting loops. The upper part is moved onto the lower part and the girth weld is performed to connect them. A special floor was designed and installed to accommodate the tools used for this welding operation. At Bouget 4, the girth weld is an orbital weld that links the upper and lower parts of the steam generator. Welding is carried out in an extremely confined space. The process took 4 years to develop and is subjected to highly stringent quality controls. Finally, the primary and secondary pipes are connected. The new heat insulation is installed with its reinforcements, blanket, stainless steel sheets and housing. In all, it represents 230 cubic meters of insulation. The steam generator replacement operation is over. At the height of the operations, no fewer than 500 people were involved on the Bouget 4 and Chinon 1 sites, not only to replace the steam generators themselves, but also to ensure that the most stringent quality and safety requirements were met. The commitment of the EDF teams played an important role in the success of the project. The doses received by the teams were lower than the initial target value. All that remains is to restore the reactor building to its original operating configuration, adjust the reactor coolant system and operating parameters, and carry out the acceptance tests. The customer can now refuel the core and reach the nuclear criticality stage for a new electricity generation cycle. Thanks to the steam generator replacement operation, the reactor can continue to operate for many years. By combining their know-how in an integrated team, Areva NP, FL, Kevervanner, and Oris were able to combine safety, quality performance, and optimized scheduling in a drive for continuous improvement. Having fewer interfaces between the customer and the consortium was a key factor for the success of this crucial operation. This experience will be repeated for future steam generator replacements in France, and there is every reason to believe that the consortium will continue to be the way forward for successful operations of this kind.